Namaskar friends, I welcome you all in this class of mathematics. Last time we discussed limits, that was direct substitution method. Now today we are going to discuss what should we do when it is failure of direct substitution method. So, we will learn a couple of methods that in the case of failure of direct substitution methods, what should we do? The topic is same, limits, failure of direct substitution method. It fails because your function becomes indeterminate form. We will take up example, so you will come to understand that what are there are 7 indeterminate forms in which the function comes. The first one is 0 upon 0. The second one is infinity multiplied by 0. Then it may come in the form infinity divided by infinity. Other forms may be infinity minus infinity. Then 0 to the power 0. In mathematics, these are called indeterminate forms. Then one to the power of infinity, and then lastly 7th one infinity to the power 0. So, these are called indeterminate forms, and if your function comes out to be any one of the forms, 7 forms given here, then we call it that it cannot be solved by direct substitution method. Direct substitution method, as we discussed last time, very simple. You are finding a limit of anything, any function at some point, say x tends to a. Then if you put in direct substitution method, you put in the function f x in place of x a, and it comes out, the result comes out. But when it comes, when you put a at the place of x, if the function comes in these 7 forms, either 0 by 0 or infinity into 0 or infinity by infinity or infinity minus infinity or 0 to the power 0 or 1 to the power infinity or infinity to the power 0, in these 7 forms, if it comes, then it is indeterminate and you cannot find out the limit from the direct substitution method. But there are other methods. In the case of failure of direct substitution method, what we are going to do. The first method is factorization. Let us take an example. So, if we have to find out limit x tends to a f x upon g x, these are two functions, real valued function. So, in direct substitution method, what you do? You put a in place of x. So, it will be equal to f a upon g a. But suppose f a is 0 and g a is also 0. In that case, this limit will turn out to be in the form of 0 by 0, which is indeterminate. So, you cannot solve it by direct substitution method. Then we solve it by factorization method. Why factorization? Because when f a is equal to 0, it means that if you factorize f a, x minus a will be its factor. Why it will be factor? Because by putting x is equal to a, the f x will become 0, because f a is 0. So, x minus a must be factor. Okay. Similarly, g a is also 0. It means that if you put a in place of x, the value of function g x comes out to be 0. So, x minus a will also be a factor of g a, because in that case this factor multiplied by something. So, if we put x is equal to a, this whole thing becomes 0. So, this is bound to be x minus a should be a factor of g a and f a. In that case, we take out we do the factorization and take out x minus a, cancel it out, and we can do it repeatedly. We can repeat this work, this cancelling. Suppose more x minus a is their common factor in both numerator and denominator function, then we cancel out x minus a more than once, and then we use again put the value x is equal to a and find out the limit. So, let us take an example. Yes. So, example is limit x tends to 3, function is in the form of f x upon g x, f x is x cube minus 3 x square plus x minus 3 divided by x cube minus 10 x square plus 27 x minus 18. So, two polynomials are there. In the numerator there is one polynomial, and in the denominator other polynomial function is there. If you put x is equal to 3 here, so it will become in direct substitution method. What happens? Put 3 here, so it will become 27 minus, it will also become 27, 3 3s are 9 into 3 27. So, it will cancel out, and 3 minus 3. So, it will become 0. And what about denominator? This becomes 27 minus 9 into 10, 90. So, 27 minus 90 plus 27 plus 3 into 3, 81 minus 18. So, you will find out 81 plus 27, 108, and minus 90 minus 18, this is also 108. So, this will become 0. So, it means that in direct substitution method it is coming out to be 0 by 0. So, this is indeterminate. So, in that case, since putting x is equal to 3 comes out to be 0, both the polynomials numerator and denominator. So, x minus 3 must be a factor of this polynomial, and x minus 3 must be a factor of this polynomial also. So, let us find it out. Limit x tends to 3, and simple high school algebra you use. So, if you take x square common here, so x minus 3 will be here plus x minus 3. In the denominator also x cube is there. So, let us put minus 3 x square for taking out x minus 3 from here, then 10 minus 10 x square. So, minus 7 x square will remain. So, minus 7 x square. So, we will then use 7 3s are 21, 21 x, because we have to take x minus 3 common here. 27 x is there, 21 x, so 6 x will remain minus 18. So, this will be equal to we take x minus 3 common in nominator. So, it becomes x square plus 1, and in the denominator here take x square, here also x minus 3 we will take common. So, we will take x square, it will become x minus 3. So, here it will become x square, then here minus 7 x, minus 7 x. So, if I take minus 7 x common, so there x minus 3 will be common here, and here I will take 6 common. So, it will become x minus 3. So, this will be the factor. Now, friends, you can see that in numerator and denominator both places x minus 3 is coming out to be factor. So, we will cancel it out. So, now this will become limit x tends to 3 x square plus 1 divided by x square minus 7x plus 6. Now, we can put x is equal to 3. So, we will get here 9 plus 1 divided by 9 minus, we are putting x is equal to 3. So, 21 plus 6. So, this will be equal to 10 in the numerator, and in denominator 9 plus 6 15 minus 21. So, it will be minus 6. So, this will become minus 5 by 3. So, friends, you see that by factorization we have found out the limit of this function f x upon g x, where in direct substitution method both are coming, the value of numerator and denominator both are coming 0. Now, let us take another example. Now, we will take another method, least common multiplier method. This is LCM, least common multiplier method. So, if the function come out to be in the form of infinity minus infinity, that is indeterminate, then in that case what should we do? Let us take an example. Limit x tends to 3. Here we take simply LCM. These are very simple method, so I am doing it quickly. X square minus 3x. So, what we will do now, you can understand the merit of the simple formula which we did before 2 class before, that limit x tends to 0 f x plus g x is equal to limit x tends to 0 f x plus limit x tends to 0 g x. Similarly, minus, multiplication, division, for everything we did it. So, we are going to use it now. So, what we will do that if we put x is equal to 3, this will become infinity in direct substitution method, and here also the denominator will be 0. So, this will also become infinity. So, this is coming in the form of infinity minus infinity. This is indeterminate form. So, what we will do, we will take LCM. LCM will be x minus 3, and this is, if you take x outside, then x minus 3 x into x minus 3. So, x square minus 3x. here x square minus 3x will come, and here minus, since this is there, so x minus 3 will come, so minus, and 3 multiplication denominator, so 3x plus 9. Simple algebra. X tends to 3. Now, this is x square minus 6x plus 9. So, let us take x minus 3 common, because again it will become 0 upon 0. So, here take x common, x minus 3, minus 3 common, x minus 3, divided by denominator x minus 3, and take x common. So, x will come here, again x minus 3. So, this will become limit x tends to 3, x minus 3, let us take common. So, here will come x minus 3, and here it is already factorized. So, x into x minus 3 into x minus 3. So, friends, here we can cancel out, you see, x minus 3 one time, then another time. 2 times we cancelled out x minus 3. So, this will be become limit x tends to 3, 1 upon x, which means 1 by 3. So, let us take another example. Limit x tends to minus 2, and within brackets it is 1 upon x plus 2 minus 6 upon x cube plus x square minus 2x. If we put direct substitution method, x is equal to minus 2, so this will become infinity. Again put here minus 2 here at x, so it will become minus 8, and it will become plus 4, and it will become plus 4. So, minus 8 plus 4 plus 4, so this will become 0. So, this whole term will become infinity. So, infinity minus infinity, direct substitution methods come out. So, we will take LCM here also, limit x tends to minus 2 and x plus 2 will be factor of this also. So, we can put this here as x cube plus 2x square minus x square minus 2x. So, if I take x plus 2 common from here, so x square minus 1, and this will be LCM of both these terms because x plus 2 is already here. So, here it will become x square minus 1 minus 6x minus 12. So, this will be equal to limit x tends to minus 2, denominator will be x square minus 13 minus 6x. So, let us see whether x plus 2 comes out to be common here. So, x square plus 2x minus 8x and minus, it should come plus 2. So, it should come minus 16. So, it means that some mistake is here. You see, I have taken common x square. Okay. So, this will be x plus 2 and then minus x square minus 2x. So, sorry, this is not 1 because this will be minus x, because here I have taken x cube plus 2x square minus x square, then it will become x square and minus 2x. So, here x square I have taken common and here minus x will be common. Okay. So, x square and here it will become minus x and then minus 6. So, minus 6x and plus 2. So, this will become minus 12. So, here it will become x square Okay. Here also I have done a mistake here. This is x square minus x, okay, and this will be, since the denominator already this is x plus 2 into x square minus x. So, it will minus 6 will come here. Okay. Now, let us go ahead. Sorry. So, this is x square plus 2x, because x plus 2 we have to take common, and then this will be equal to minus 3x, because x square minus x is there, so it will come minus 6x and minus 6. Here x plus 2 x square minus x. So, if I take common x plus 2, here it will become x minus 3, okay, and here x plus 2 into x square minus x. This is limit x tends to minus 2. So, x plus 2 will be cancelled out, and if we put x is equal to minus 2, so it will be minus 5 upon, it will be equal to 4 and plus 2, 6. So, this will be equal to minus 5 by 6. Now, we will come to third method, that is, sometimes we have to do rationalization, either numerator or denominator. Some functions are there, so we rationalize it and then we take common factor outside, and then by substituting a in place of x we get the result. So, we come out from the indeterminate form. So, let us take an example. Say limit x tends to 2, 3 plus x minus root 5 divided by x minus 2. Now, in direct substitution method, if you put x is equal to 2 here, so it will become root 5 minus root 5. So, it will become 0, and this denominator will also will become 0. So, it will come out in the form of 0 upon 0, which is indeterminate. So, we rationalize. How do we rationalize? You know, from the high school mathematics, we will multiply both in numerator and denominator root 3 plus x plus root 5. Here it is minus, so we will put plus, so that we will use x minus y into x plus y is equal to x square minus y square. So, denominator and denominator we have to multiply with the same thing, otherwise the things will change. Okay. Now, this will be equal to limit x tends to 2 and this will be equal to 3 plus s, because this square minus this square. So, this square will be 3 plus x minus this square root 5 square will be 5, okay, divided by x minus 2 into under root 3 plus x plus root 5. So, 3 minus 5 equal to, because it will become minus 2. So, it will become x minus 2. So, it will be equal to limit x tends to 2. In the denominator it came out to be x minus 2 and in the denominator x minus 2 is already a factor and this will become root 3 plus x plus root 5. Now, x minus 2 will be cancelled out both denominator and denominator. So, it will be equal to limit x tends to 2, in the denominator only 1 is remains and here root 3 plus x plus root 5. So, now we can substitute x is equal to 2. So, it will become 1 divided by putting x equal to is equal 5 root 5 plus root 5. So, 2 root 5. We can also write it as if we want to rationalize the denominator. So, root 5 upon 2 into 5. So, it will be equal to root 5 upon 10. Now, the fourth method I will explain. This is use of some standard result. So, these result has to be kept in your memory, so that you can use it when it comes in the function, and then you can solve the problems of limit. So, I am writing the formulas and it is also given in your book. You can see it. So, these are not difficult. Limit x tends to a, x n minus a n divided by x minus a. This simply becomes to be n a n minus 1. You see, quite simple. You have to remember another limit. Suppose trigonometric function is there, theta tends to 0, sin theta upon theta. So, if you put the direct substitution, sin theta will become 0 and this will become 0. So, it comes out to be 0 by 0, but this you should remember, this comes out to be 1. Now, third application is limit theta tends to 0, cos theta is equal to 1. You know cos 0 is equal to 1. So, in the trigonometric function, this limit function we can use. Fourth one, similar to sin theta upon theta, limit theta tends to 0, tan theta upon theta. This also comes out to be in the form of 0 by 0. So, this is taken as 1. Similarly, its reverse, theta is equal to 0. Suppose theta upon tan theta. So, this will also become to 1. A to the power x, limit x tends to 0, a to the power x minus 1 divided by x. So, this becomes to log base e mod of a to the power x minus 1 divided by x. If x tends to 0, its limit becomes out to be log base e of a modulus of a. And in particular, if it is e, say limit x tends to the power 0, e to the power x minus 1 upon x. So, this becomes from this formula log e, and you know log e, it will become 1. Now, sixth one, limit x tends to 0, log of 1 plus x divided by x, this is equal to 1. And two more formula are there. Seventh one, limit x tends to 0, log of 1 plus x divided by x. These are all indeterminate form, because if we put x is equal to 0, this will come out to be indeterminate form. So, you must remember this formula. This becomes 1 so we have already done it. Okay, the sixth one, seventh one is limit x tends to 0, 1 plus x to the power 1 by x, it will becomes to e. And finally, the last formula should remember is limit x tends to infinity 1 plus 1 by x to the power x is equal to e. So, friends, we have learnt that in case of failure of direct substitution method, what should we do? Because if it comes in the form of indeterminate form, that is 0 by 0 or infinity minus infinity or infinity by infinity or 1 to the power 0 or 1 to the power infinity or infinity to the power 0, in such forms these are called indeterminate forms. So, in such cases we used other methods. First we learnt the factorization method, that in case it is coming out to be 0 and 0, and if two polynomials are there f x and g x, then if the value of f a and g a is both coming out to be 0, it means that x minus a will be factor of both f a and f x and g x. So, we factorize it and we cancel out the factor x minus a from both numerator and denominator, and then we can find out the result. And then we learnt the least common multiplier method, in which if it is coming out to be infinity minus infinity, so then we take the least common multiple LCM, and then we do the simple algebra, and then after factorization some factors will be cancelled out in the numerator and denominator, and then we can find out the value of limit. Then we learnt the rationalization method, where if denominator or denominator if a square root or irrational numbers are coming in the denominator or denominator, so then we rationalize it by multiplying both in numerator and denominator, and then it may come out that some factors will cancel out and we can find out its value. Then we learnt some standard results, standard formula including trigonometric and logarithmic function, so that we can find out the limits using these formula. So, today we will stop here. In the next class we will do examples on the standard results. So, these are quite interesting and fascinating examples, and not difficult, very easy. The only thing you should remember the standard results, and then you can easily solve the problems. So, friends, I hope you must have enjoyed the class today, and next class we will see the examples. Thank you very much.